All right, we're 60 seconds early, but we might as well get started because I'm just going to ramble for at least 60 seconds. Thanks, everyone, for coming to the Intro to Linkerd session. Hopefully, that's what you were expecting here. If you could just lock the doors at the back, no one is going to be able to escape here until you have successfully installed Linkerd on your laptop. My name is William Morgan. I'm one of the maintainers of Linkerd. Mostly my maintainership these days consists of editing the README and sending out emails and things like that, so I don't actually write a whole lot of code. But I've been involved in Linkerd since the very beginning of the project. And I've done this intro session at almost every KubeCon since the beginning of KubeCon. Not everyone, but almost everyone. And usually, I've always tried to make it a little different. In the past, we've brought up community members and had them do lightning talks and things like that. The feedback that I've gotten is people actually want an introduction. So this time, I'm going to try and actually do an introduction. I'm going to leave a bunch of time at the end for Q&A, because I'm sure there's going to be good questions. And let's see, we have until, just make sure I have the timing right. So we have until 12:30. OK, great. So we should have plenty of time for questions. And then one last thing I'll point out is that this slide deck is a very modified version of a public slide deck that we have that we give out to anyone who is doing a Linkerd meetup or a Linkerd talk. So everything you see here is up on sketch.com, but you can also present it yourself. OK, so let's start with what is Linkerd. I have the answer right here for you. It's a service mesh. Hopefully, the term service mesh is familiar with you, and hopefully you know that you need a service mesh. You might not know what it is, but you know that you need it. And I'll explain what a service mesh is. Linkerd was the very first service mesh project and the first project to coin that term. And so very early on, and I'll go through the history in a second, early on, a lot of this kind of talk was describing what a service mesh was and why it was so important and trying to convince you this was an object you had to have in your brain. Nowadays, it's a different kind of conversation, so I don't have to do quite as much evangelization about the service mesh concept. I have to do a lot of description of what Linkerd is. So Linkerd is also a CNCF project. Hopefully you saw the keynote earlier this morning. Fun fact, it is actually the only CNCF service mesh project. If you look at the CNCF definitions, there are related projects, but there's only one so far that is a service mesh. We've been in production for over 24 months, a very healthy community, primarily centered around the Slack channel. So if you're trying anything with Linkerd and you get stuck, please hop into the Slack channel. Can everyone hear me OK? OK, that's good. I hear the other speakers really loud. Hey, quiet down. OK, I'll try to stay focused. I'm also running on about 3 hours of sleep, so wish me luck. Very healthy community around the Slack channel. Lots and lots of GitHub stars, which, as we all know, is very important. Lots of contributors. And we have a crazy cadence recently. We've been doing almost weekly Edge releases and a stable release about every 6 weeks. So momentum around Linkerd has never been higher. I put up a bunch of our production users. There's a lot more out there. And fundamentally, Linkerd is a community project. So it is owned and created and contributed and run by you. You are all members of the Linkerd community. By being in this room, I officially anoint you. So you should feel ownership of Linkerd because you have as much ownership of it as I do. OK, so why use Linkerd? And this is kind of the service mesh value props. OK, so when we talk about the service mesh, we talk about, I like to frame it into three kind of components. There's a set of functionality around visibility, or we might call it telemetry or observability. Right? So we want to give you things like the golden metrics. So what's the success rate of my service? And what is the latency distribution of my service? And what's the throughput in requests per second or requests per minute of my service? Right? There's a set of features around reliability. So retries and timeouts and circuit breaking, load balancing at the request level. Those are all features that are centered around making the system more reliable. And then there's a set of features around security. Right? So things like the transparent mutual TLS that we saw in the keynote demo, where we try and give you these security primitives without you having to do a lot of configuration. I'll get into some of the kind of strategy behind Linkerd in a second. But with all of these, with these three value props, there's something really interesting, which is number one, the service mesh cannot be a complete solution, right, for any of these. So it's not a complete security solution. Right? There's still a lot more you have to do to have a secure system. It's not a complete telemetry system. You have to instrument your application. You have to do things like tracing, and you can't just offload that to the service mesh. It's certainly not a complete reliability solution because the application has to do a bunch of other work to make the system as a whole reliable. But the distinction is Linkerd can grab a lot of that functionality out of the application and bring it down to the platform layer. And that's the real value, right? Is that the developers no longer have to spend their precious brain juices worrying about what are ultimately platform features, right? So what is fundamentally common about all of these features is kind of three things. Number one, they are independent of business logic, right? None of this stuff is related to what your business is actually trying to do, right? Okay, so that's feature number one. Feature number two is they're difficult to get right. So even something like retries, how do I do retries? If you do something naive, you end up in a very complicated and difficult situation that you have to extract yourself out of. Distributed systems are difficult, right? Especially in their kind of aggregated effects. And then feature number three, all of these features that I've listed here work best when they are applied uniformly over everything, right? So something like mutual TLS, if you have one service that implements that, well, okay, that's great, but that doesn't get you very much. If you really want the value out of that, you want to have every service implement that. So those three features are hallmarks of functionality that is ultimately platform functionality, and the value of the service mesh, the value of Linkerd, is we pull that stuff out of the application and put it in the hands of the platform owners where it belongs. Does that make sense so far? Okay. All right. Okay, we created the service mesh. We invented it. There was nothing. It was just void. And then Linkerd came, and it was like a blazing light. This was way back in 2016, was the very first version of Linkerd. The history of Linkerd, I'm not going to go into too much of this, but I and some of the other Linkerd creators were engineers at Twitter, and Twitter went through this whole microservices decomposition. We've written about this, so you can read about it online. About a year later, it became a CNCF project. I think it was the fourth or maybe fifth project at the time. It was like Kubernetes and Prometheus and Fluentd and something, and Linkerd. And then Linkerd went through a big transformation last year, culminating in the release of Linkerd 2.0 in September of last year. And right now, there's two parallel branches of development. There's the 1.x stuff, which is very powerful and very configurable and multi-platform, but it's built on the Twitter stack. So it's built on the JVM and Finagle and Netty and Scala. And it is rich. It's very rich. It's also difficult to learn. And then there's the 2.x stuff, and most of what I'm going to be talking about is 2.x because that's where most of our energy goes these days, which has been rebuilt from scratch on Go and on Rust, and it's very, very Kubernetes specific. So 2.x right now, still playing a bit of feature catch-up with 1.x, and also very Kubernetes specific. We will get there eventually. We'll support the world outside of Kubernetes, if that world even exists in another year. We'll get there, but if you're looking at the feature matrix, we're still catching up with 2. The reason why 2 has so much energy behind it, of course, is because it's much faster and much smaller and much lighter weight. Okay, and that's kind of the design goals. If you go to InfoQ, if you search for like InfoQ, Linkerd, V2, I wrote a whole long article about this, so you can get into all the gory details of the project history. But we learned a lot. Suffice to say, we learned a lot in getting 1.x to production at companies around the world, and we took a lot of those lessons and incorporated them into 2.x. And I know that the very first question that someone is going to ask is, what's the difference between Linkerd and Istio? And I will answer that. Even though it pains me inside, I will wait for you to ask that, and then I will answer it. And it's going to come back to these design goals. Okay, so the design goals for 2.x are we wanted to make it so it just works. If you have a functioning Kubernetes application and you install Linkerd, the application should continue to function, right? Turns out that's actually hard to do. And you should get there without having to spend hours, weeks configuring things. And that was actually a problem with Linkerd 1.x. It was very rich, but you had to learn a lot of stuff. We wanted to make Linkerd 2 very, very fast and very, very small. Okay, right? You should introduce the bare minimum of cost if you're adapting the service mesh. And that's a theme throughout this. And finally, we wanted to make it understandable. Sometimes we call this simple. This is actually the hardest thing. We wanted to make it so that you, as the operator of the service mesh, you've already installed Kubernetes. You're already swimming in APIs and CRDs. You've added a lot of kind of cognitive overhead to your system. With Linkerd, we wanted to minimize the additional cognitive burden that we're placing on you, because our primary audience for Linkerd is the operator, is a platform owner, is a person who actually has to wake up if this thing breaks at 3 in the morning, right? And that can be either a very complicated, difficult system, or it can be a very simple system that's easy to reason about. So simple doesn't always mean easy. Simple means understandable and clear and introspectable. All right, so I'm going to show the architecture diagram, I think, in the very next slide. Is this making sense so far? Am I inspiring you with the vision of this magnificent project? Oh my God. Wow. I've never seen a project like this before. All right, so the data plane, and I'll show you the diagram in a second. Data plane is written in Rust, and it is called simply Linkerd proxy. It's in the Linkerd 2-proxy repo. The control plane is written in Go. And the data plane proxies are super, super fast and super small. And there's all this cool stuff we can do in Rust to make them really memory safe and all that, a bunch of other things that I kind of half understand. The control plane in Go has much more relaxed requirements around latency. Goes pretty fast, but is not as fast as Rust. It has much more relaxed requirements around latency, and it's a lot easier to get involved in a Go project than it is to get involved in a Rust project, in my humble opinion. And it's also a pretty natural fit for us because the Kubernetes ecosystem is very Go-centric, so there's a lot of libraries and things that we can kind of make use of in the control plane. OK, so if you draw it out, I said this was simple, didn't I? OK. So if you draw it out, just look at the blue boxes. It's not that bad. So the bottom bit is the data plane, okay? And this is similar to the way that most service meshes operate. Not all of them, but most of them, which is you have your application. Okay, that's your service logic, right? That's like one container. And then the blue thing is a pod around that. And we insert that proxy in there. And we do it in this magic way where you don't have to worry about all this stuff. We can do some IP tables magic to wire. Oh, yes. Some IP tables technology, not magic, to wire up all TCP traffic so that everything coming to and going from the application container goes through the proxy. Okay? And then that proxy is, as you expect, is proxying all of that traffic, and it's also communicating with the control plane. It's sending a bunch of, it's asking it for like what the latest policy is and what do I need to know about how to do this. And then the control plane is also extracting metrics from the policy, from the proxy. The control plane we split into a bunch of components because it makes sense. And I'm not going to go into each of those, but you'll notice that there is an identity component in there that was featured in the keynote. That's actually a little certificate authority, and it's generating certs and distributing them to the proxies. There's a destination service, which is doing kind of talking to Kubernetes API and asking it about basically service discovery information. And there's some other components in there. If you go through the docs, this is all pretty well documented on Linkerd.io. But the point is, you have a data plane, and that data plane sits next to your application. It has to be really fast. And then you have a control plane. The control plane sits off to the side. That makes sense so far? OK. Very coarse-grained view of the roadmap. So Linkerd 2.3 was released last month. Yep, that's right. And it has a bunch of cool features, all the telemetry stuff. Retries, timeouts, auto-inject, the TLS stuff on, mutual TLS on by default. It's all zero config. There is some configuration you can do if you want to. There's something very, very cool called service profiles that you can enable in Linkerd. And there's a whole talk about them later today. Later in this conference by one of the Linkerd maintainers. I'm going to give you a whole list of the talks that you can go to. Service profiles are super, super cool, but they are opt-in. Okay, and then 2.4, which is coming out next month, will have traffic shifting, so we'll be able to do blue-green deploys and canaries and things like that. You can kind of do that with Kubernetes already by doing label flipping on pods, but you're restricted to pod level granularity, and that's not always right. So service mesh can add some value there. And then beyond that, we're going to start getting into things like policy, right? I got my security team. They want to allow things, or they want to deny things. They're always denying things. Or mesh expansion, which is how do I get the data plane able to run outside of Kubernetes? So I still have the control plane running in Kubernetes, but now I can start expanding the beauty of the mesh to my legacy systems. And by legacy, of course, I mean not Kubernetes. And then there's a whole bunch of other cool stuff that we can get into. But again, Linkerd is a community project, so if there's something that you want in it, you have the power. I empower you as members of the Linkerd community to make that pull request. And we'll walk you through it. We'll do the review. We'll do a nice review with you. We're very friendly. OK, so at KubeCon EU, first of all, if you have been to the expo hall, there is a big Linkerd. It's not that big. We didn't pay that much money. A medium to small size Linkerd booth. A lot of Linkerd maintainers are hanging out there. They want to talk to you. They spend all day, these poor people spend all day in Slack just getting issues and bug reports thrown at them. They're desperate for a human connection. They just want like something friendly. So go make their day by saying hi to them. And then we have, I think there's over 10 talks related to Linkerd throughout the week. You can type this link into your browser right now. 2LVK, Linkerd Very Cool Limited. I'm actually going to click on it. Let me, I'll zoom in here. I'm not going to go through this in gory detail, but I'll at least show you where's my mouse? Come back. There we are. Let's see. OK, so this stuff has more or less already happened. This is where you are right now. There's a cool talk that's actually not 100% related to Linkerd, but is indirectly related by one of the Linkerd maintainers, scavenging for reusable code in the Kubernetes code base. So if you want to know about what is inside Kubernetes and how we had to unpack some of this stuff to figure out what to do with Linkerd, you should go to that. At the same time, Mosen, one of our prod users, is talking about how he processes billions of dollars using Linkerd. So you can pick and choose whether you care about money or code, because they happen at the same time. I'm going to be on some panels. Skip that. That's boring. There's a bunch of other interesting talks from some more production users. And then if you use VS Code, there's a really cool VS Code Linkerd integration that will be featured as part of this talk tomorrow from some of the Microsoft folks. If you are into cool observability, auto-scaling stuff, Frederick, one of the Prometheus maintainers, will be pairing with Siggy, who's one of the Linkerd maintainers, to talk about Thanos and Linkerd. If you want to know about Rust or about gory technical details, then please come to the deep dive, which is on Thursday. And then finally, the service profiles thing that I talked about early on, you can come talk to Alex, or come see Alex's talk about that. What service profiles allow you to do, I'll give you the one-line summary, so maybe you can decide you don't want to see this, is they allow you to give Linkerd information about your service, including what are the paths or what are the routes that it expects, and then Linkerd can start doing stuff with those routes. For example, it can give you route-based metrics. So we can say, oh, what's the success rate, not of my service as a whole, but what is the success rate of get /users or whatever, some route, some gRPC. Let's say we're using gRPC. Get user by ID or whatever. Give me the success rate by that. Specify retry policy on a per route basis. So there's all sorts of really cool stuff that it enables and allows you to get more fine-grained than just specifying things at the service level. OK, so I'm going to go back here. So yeah, feel free to type that link into your browser. We also, on Saturday, a very friendly company called Kinvoke, which some of you may have encountered before, did some Linkerd benchmarking. And so if you want to know what the cost of adding the service mesh to your system is, then either type this URL in by hand or just search for Linkerd Kinvoke or something like that. We measure the cost both in latency, so how much latency does it add to requests, which of course you have to measure as a distribution, so it's a little tricky to talk about. How much memory is required, and how much CPU is consumed. OK, and then that's really it. We have 15 minutes left for Q&A. Wow, I hope you have some questions. First, let me say before we start doing questions, everything in Linkerd is open source. Everything's happening on GitHub. All the roadmap stuff is up on GitHub. Well, I should say anything that's not happening in GitHub is happening in Slack. So hop into either of those. We do have some formal, or we do have mailing lists where we kind of send announcements to. For whatever reason, everyone likes talking on Slack and no one likes talking on the mailing list. So make of that what you will. We have a really friendly, welcoming community. Like I said, Linkerd is a community project, and you are all members of that community. So feel free to hop in. And with that, why don't I open it up to questions. You have to ask the correct first question, and then you can ask a second one if you want to.
To what extent has Twitter implemented 2.0 in the stack?
That was not the correct first question. OK, so Jamie asked, to what extent has Twitter implemented Linkerd 2.0 in the stack? And that's actually a very easy question. The extent is 0. They are very much invested in their Finagle-based, JVM-based stack. I have been out of Twitter for nigh upon 5 years, half a decade. So I only know what I see from the outside, but they continue to be investing heavily in something that's much closer to the 1.x stack of Finagle, Netty, JVM, and doing that stuff in process. So they're also very heavily invested in Mesos. They're starting to adopt Kubernetes. That may be news to some of you. They're starting in that direction. That's public. But that's where they are. All right, who wants to ask the correct first question? I already called on someone in the front. How about the young man with the red hat? Istio versus Linkerd. So first, thank you for asking that question. And I understand why people ask it, because they ask it all the time. But I hate that question. But thank you for asking it. And the reason why I don't like answering it is because I don't really care about Istio. It's irrelevant to anything that we are trying to do with Linkerd, right? The goal of Linkerd is we want to give you all the value of the service mesh in a way that minimizes the cost that you're paying, right? Minimizes both the resource cost, right? Low CPU and low memory usage, but more importantly, minimizes the mental cost, right? And in that, if that's the goal, who cares what happens in some other project? But I understand, why you asked that question, and I'll try and answer it in a way that does not involve me speaking for Istio. I think, so the goals, the value props, let's say, of the two projects are the same, right? Or at least very, very similar, right? That early slide that I showed around visibility and observability, visibility and security and reliability, you could almost take that same slide and apply it to Istio. I had some cool screenshots in there that you'd have to replace with less cool screenshots. But those value props are kind of the same. In my view, the difference is really a difference in focus. So for us, that focus on operational simplicity is a thing that is paramount in Linkerd's design. And it means that we do that at the expense of features. And I think the trade-off, my impression is the trade-off is the other way in Istio. So for us, we would rather have something that is simpler and that's easier to reason about, even if it means we have to be slower on features or we have to sacrifice features, than do it the other way around. And I think that's the fundamental difference. I would ask that same question to a nice Istio person. You might get a different answer, but that's my view. Yes?
This might be a naive question. Do you not think something like a service mesh should be embedded further down the stack in Kubernetes itself rather than being separate?
So should the service mesh be embedded in Kubernetes itself rather than being a separate layer? Let's take a vote. If you think the service mesh should be rolled up as part of Kubernetes, raise your hand. OK? That was a small number of hands. If you think it should not be rolled up as part of Kubernetes, raise your hand. Okay, and some of you did not express an opinion. Okay, so I think that's a really good question. In my view, it does not make sense to roll it up as part of Kubernetes because the set of functionality that it has is very different, and it's kind of outside of Kubernetes' domain. And what I think Kubernetes was very good at was setting that boundary of like, this is the stuff that Kubernetes is going to do. And so, for example, when I give a demo of Linkerd, one of my favorite demos is I'll start with an application that has a bug. I'll deploy it on Kubernetes, and then we'll click around in the application, and we'll see 404s. Okay, and then I'll look at the Kubernetes dashboard, and everything's green. And I'll say, look, this is not a problem with Kubernetes. Kubernetes just doesn't know anything about the traffic, kind of the layer 7 semantics of, OK, is this a 500, is this a 400, or is this a 200? And Kubernetes should not know about that. So in my opinion, they play nicely together. And a lot of that is intentionally, but they really focus on different parts of the stack. So thank you for that question. OK, at the very, very back, you might have to yell. I couldn't hear that, I'm sorry. UDP support. Are we planning UDP support in Linkerd? I'm not against it in principle, but it's not currently on the roadmap. There's already so much stuff we have to do with TCP. But there's no reason a priori why we couldn't do that. So if that's something that's interesting to you, it'll involve a little Rust programming, but could be pretty cool. OK, in the back. Yeah, good question. So the question was, there's a lot of service mesh discussion and technology and documentation around HTTP, and I think by extension HTTP2 and gRPC. What about queuing? What about message queuing? There's no reason why the service mesh cannot extend to that. It's not the starting point because, well, for a variety of reasons, but that's a pretty natural extension. Some of the stuff that Linkerd does that's very good at for HTTP requests doesn't make as much sense for something like Kafka. Like we're not going to have Linkerd, I don't know, would we have it do retries? Maybe we would. It's not quite as salient of a problem, but yeah, in principle, and I suspect, in fact, I think we had a GSOC project, and I forget whether we approved it or not, around adding Kafka support to Linkerd. All right, I think we have time for a couple more questions. Yes?
Let's say you're using Datadog and monitoring, how is it integrated?
Yeah, that's a great question, and I didn't even talk about any of this stuff. So the question was, what if you're using Datadog for monitoring? Like, how does that integrate with Linkerd? And so I skipped over this entire thing, but let's go back to the architecture diagram, and you'll notice that in here we have a little Prometheus instance up there. Okay, so that Prometheus instance, what's happening is it is talking to each of the Linkerd proxies, and it's extracting their metrics, and it's aggregating them. Okay, and if you are familiar with Linkerd 1, you'll know that this is a big difference because in Linkerd 1.x, we exposed those metrics, but it was kind of up to you to do anything with them. So now we're actually able to aggregate them for you, but by design, we keep that Prometheus instance really, really small. We time limit it. I think it's somewhere between, I think it's 6 hours, but it might be 2 hours in the future. Thank you, 6 hours. And it is it's a temporary place. It's like going to jail before you go to prison, or prison before you go to jail. I don't know which happens first. You need to get metrics out of that. You need to put them somewhere real. And that's where Datadog comes in. So if you're using Datadog, I would use a Datadog to Prometheus adapter and suck all the metrics out of Linkerd's Prometheus and throw them right into Datadog. Yeah. And if you're using another system, almost everything has Prometheus adapters. So that's how you get it out. Yeah. Yes? Is it reasonable to use Linkerd if you have a RabbitMQ connection? So I think that's very related to the Kafka question before. Right now, if you use it today, Linkerd will treat that as a TCP stream, and so we'll give you like byte level metrics, which is something, and we can encrypt for you. That's something, I think it'll be improved if we had 0MQ protocol support, just like the Kafka level protocol support. So yes, it's reasonable. There's probably some more work we could do to make it even better. Yeah?
Does it support database application like MySQL, Postgres?
Does it support databases? Yes, so very similar answer to the 0MQ question, or the RabbitMQ question, which was, great. Maybe they'll be quieter now. How come you guys did not applaud with such vigor? When I'm done with questions, I'm going to ask for like a really rousing ovation, and then we'll show them who had the better talk. So yeah, same story. Right now, we will proxy it. We'll treat it as a TCP stream. We don't understand the protocol, so maybe we'll do TLS, but we won't be able to break things into like, oh, this many. We can't give you like latency metrics on like the SQL queries or anything like that. If we add MySQL support, add protocol support, then we'll be able to do that. That's actually a little more complicated because MySQL is a stateful protocol, and there's like this notion of connection level state, so things get a little more complicated. But in principle, it's just a matter of code. Just to open a PR. OK, hold on, let me check the time. Oh, yeah, in the very, very back. That is an excellent question. Can Linkerd be enabled selectively? Unfortunately, Linkerd can only be installed across your entire company all at once, or you don't get it at all. Yeah. So there's 2 phases to installation. You know, the other thing I should point you to, I'm going to answer that question by way of showing you this website called linkerd.io. If you go here and you click on Get Started, okay, it's going to ask you to choose your platform. Like I said, 2.x only supports Kubernetes, so you click on that. And then we'll give you a bunch of commands for how to install it. And basically, you install the CLI. Okay, and then you install the control plane, okay, and that control plane is going to sit in a namespace, but it's not going to do anything until you add a service, until you add the data plane to a service. And adding the data plane to a service, which means injecting those sidecar proxies, can be done one service at a time, potentially even one pod at a time, though usually it's one service at a time. So we try and make it, to answer your question, we try and make it very easy to be incremental about it, because we don't want the service mesh to be an all or nothing proposition, right? This goes back to the philosophy of it should not be this massive layer of infrastructure that you have to stick on top of all this other stuff. It should feel like a tool. It should feel like I don't know, what's a cool tool? A drill, electric drill. Well, that guy's smiling, so I'm going to do the smiling question first and then the frowning question second. All right, smiley.
Follow up on the previous question.
Follow up, OK.
Selectively enabled on just the number of ports or like not for the metrics, but only for the REST APIs.
Can you selectively enable Linkerd on just some number of pods? Oh, ports. Oh, ports. You can with a little bit of, so this you actually have to do a little configuration. So I apologize. You'll be violating our 0config goal. But you can tell Linkerd not to, you can tell, I believe you can tell it to exclude certain port ranges if you want to. Yeah. OK, and then frowny.
Yes, it's a 2-part question.
2-part question. I see why you were frowning.
The first part is the design decision to make it on by default for MTLS.
Uh-huh.
I was curious to know if that's what customers requested because of potentially.
Great question. OK.
And second part was, what if you are selectively deploying Linkerd on certain pods and you have MTLS on by default, but one of the containers or recipients doesn't have? How do you?
That's a great set of questions. You guys are going to like this. OK, so number 1, why was MTLS turned on by default in Linkerd 2.3? Was that a request from customers? No, it was a philosophical decision, which is that security should be free, man. Like, you shouldn't have to do a bunch of complicated shit to get security. You should just get it, right? And like, obviously, Linkerd is not a complete security solution by any means, but to the extent that we can democratize access to all this stuff, you know, you should just have that. There's no reason. So the way I look at it is, you know, every time I use my web browser and I'm talking to a website, I'm looking at cat pictures on Reddit, like I get a green lock icon and I'm not doing any work, right? And that's for cat pictures. So how come my application, which is, you know, processing like credit card numbers and social security numbers, hopefully both at the same time, how come that's not encrypted? How come I don't have a green lock icon there? So I want to give you that green lock icon. So that was a philosophical decision. And then the second part of this incredible two-part question was, what happens if you have TLS on by default, but then you deploy Linkerd incrementally? This is like you're combining your own question with someone else's question. That's a really good question, meta question. The answer is right now in Linkerd, we do not enforce TLS communication. So if you are making a connection to a destination that does not have a Linkerd TLS enabled proxy on the other side, we allow that to happen, and you get an unencrypted connection. Because it's either that, or we have to like start breaking things, right? So in the balance between keeping things working and being a complete security solution, we are erring on the side of keeping things working. Now, I think there's a later stage in which we add more policy where we say, you know, you could enforce TLS, and like if you don't make a TLS connection, then you get denied. But that is, I see that as a later stage concern. Right now, it's more important to give people more than what they have now, even if it's not always, you know, 100% perfect. Okay, Jamie, did you have another question?
I'm good.
Okay, good, because we're out of time. Thank you very much for staying with me to the end. My name's William Morgan. Thank you. Standing ovation.